Hey Wildcats, it's Miss Austin again. So we've been talking a lot about matter in the last few weeks. Well, today I'd like to talk to you about changes in state. So what I have here with me is a beaker that's filled with ice. So if I were to add heat to the ice, what do you think would change about the ice's properties? Let's start by talking about some of the properties of the ice. So ice is a solid, as you've learned. It's also really cold, but let's find out the actual temperature of the ice by using a thermometer. So I will put the thermometer in here, and I am watching the temperature fall a little bit, and I will give it a few seconds to get down to the right temperature and come back at you. Okay, so I've got the temperature of the ice, and it looks like it's 46 degrees, and that is in Fahrenheit. Now, it's hard to tell the exact temperature of the ice because the best I can do is put the thermometer down into the beaker, and I can't stick it inside the ice cube, so it might be a little colder than that, but we're going to call it 46 degrees Fahrenheit because that's what it's measuring. Okay, so now what do we say about the shape of the ice? Let's see, I'll take a piece out. So we've got a lot of different pieces. They're kind of square-like, and there's several of them in there. Okay, and we also want to know the mass. Now, because the ice is in a beaker, if we want to find the mass of just the ice, we need to know exactly what the mass of the beaker is. And I determined that earlier on this balance, which is called a triple beam balance, and the mass of the beaker is 157 grams. So now I'm going to find the mass of the beaker with the ice in it. I'm marked on my cup. All right, I'll put it on here, and I'll go, it's greater than 100, greater than 200, greater than 300 grams. Oh, it's less than 4. So we'll go back to 300 and start counting by tens. 10, 20. I'm going to go up to, well, 50 was too much, so I'll go back down to 40. Oh, I guess 30 is too much, so 320, and now we'll go by ones. And what I'm looking for is for this line right here to get to right on the 0. That's how I determined the mass earlier of the beaker. All right, let's see. All right, you can tell that it's right about at the 0, so we're gonna say that the mass of the beaker with the ice in it is 324 grams. So I will write that down. Look, I got my marker wet, it doesn't want to write. 324 grams. Okay, so now to find the the mass of just the ice, I'm going to need to subtract the grams from the beaker from the total number of grams. 324 grams minus 157 grams is 167 grams, so that's the mass of the ice. Now let's go heat up the ice and see what happens. Okay, to heat the ice, we are going to use this hot plate, and it's been on for a while, so it's already hot. Now, by the way, you should never go near a hot plate without adult supervision because it's not safe. So now we're going to put the beaker of ice on the hot plate, and you can see the ice has already started to melt just a little bit. That's from being just in the room because there's more heat in the room than there is in the freezer. But we will just watch and see what happens. All right, the ice has been on the hot plate for a few minutes, and you can see that some of it's melted. There's more water than ice, it looks like, in there now, but we will just keep on watching. Well, we can see that more ice has melted, but it's still going pretty slowly. So I'm gonna go ahead and stop the video, and I will come back when the ice is almost completely melted. Now, I'm not gonna touch anything. I'm gonna leave it exactly like it is on the hot plate. So I'll be back in a few.
A little longer than a few minutes later.
Okay, now all the ice has melted, and what we are left with is a beaker of water. So I'm going to turn my hot plate off, and let's look at the properties of the water. Okay, we have the temperature in the water, and the water looks like it's just under 80 degrees. Looks like it's at the 78 line, so we will call that 78 degrees. Okay, what about the shape of the water? Remember that liquids take the shape of their container, so the water is pretty much the same shape as the beaker. If I were to pour it into a different container, it would take that shape. All right, so now let's check the mass. So the beaker of ice was 324 grams. So I'm gonna start with that. 324. Now you can see that we're not balanced, so we lost a little bit of mass, but not much. Looks like it's trying to balance now. So it is pretty much balanced. So we are going to say that the beaker with the water has a mass of 323 grams. And when I subtract the 157 grams of the beaker from the 323 grams of the beaker with the water, I know that the mass of the water is 166 grams. So let's now compare the properties of the solid ice with the liquid water. So what we can see is that the mass of the ice was 167 grams, the mass of the water was 166 grams. So even though the water takes up a lot less space in the beaker, the mass is almost the same. And my guess is that we lost the 1 gram of mass because of condensation, which is something we'll talk about another time. And look at the temperature. So the ice was measuring at 46 degrees Fahrenheit, and the water was measuring at 78 degrees Fahrenheit. So it did get quite a bit warmer, and it definitely changed state from a solid to a liquid, but it kept almost the same mass. I hope you enjoyed comparing the properties of solids versus liquids with me when we changed the state of matter from a solid to a liquid. Next time we will do the opposite. We will cool some water and we will see if we can change the state to solid. So I'll see you then. Bye.